Friends, very good morning to everyone. Let us deal with a new intermediate, that is carbanions. We have studied about carbocations. As we know, carbocations are positively charged electron deficient carbon. Another set of intermediates are formed, which are carbanions. Today's subject of discussion is this carbanions. Like that of carbocations, carbanions are the other set of intermediates formed during the course of the reaction. Carbon atom, which is carrying a negative charge, is a carbanion. A negatively charged electron rich carbon species is carbanion. It has 8 electrons in its valence shell. 6 comes from the 3 covalent bonds and one set of lone pair of electrons are formed. When an heterolytic cleavage occurs in a bond, when carbon retains both the electron pairs in the cleavage process, it results in carbanion formation. If at all electrons are taken away by the leaving group, then a carbocation is formed. Here you see here the heterolytic cleavage has occurred between C and Z. The electrons are retained by the carbon. Heterolysis has occurred. A carbanion is generated. It is quite opposite process of carbocation. In carbocation formation, the electrons are taken away by the leaving group Z. Here, the electrons are left on the carbon and Z, the leaving group, leaves without the electron pair to give a carbanion. Carbanions, as they are electron rich, they can act as a good nucleophile. The carbanions has a very important role to play in our industrial products preparation like plastics. As we know, plastics has revolutionized the world, and also it has created a great menace to the mankind. Yes, plastics has its own advantages when it is used in a manner which it has to be used. Means it should be optimally utilized. Overutilization leads to problems. Let us come to carbanions. In 1984, Olmsted prepared a stable carbanion. He took triphenyl methane and treated with N-butyl lithium. As N-butyl lithium is a strong base, it can abstract a proton from the methyl hydrogen and it gives rise to a carbanion. And it was to this product what is formed, it was he added 12 crown 4 lithium crown. When he added crown ethers, he got corresponding triphenyl methyl carbanion salt, which is a stable salt. The carbanion, these are stable carbanions. This can be prepared in the stable form also. As we know that carbon ions are reaction intermediates with heavy electron richness. Because of this richness, it is highly reactive. As these are highly reactive, they are non-isolable. Carbon ions can be prepared by many methods. One of the methods is by proton abstraction from the organic compound having acidic hydrogens. In an organic compound having acidic hydrogen, as we know that an acid is a proton donor, it donates proton easily. And to accept that protons, we need a strong base. The strong bases which we can use are either hydroxide ions, NH2 minus ions, or alkoxide anions. As we see here, a ketone with alpha hydrogens are acidic due to the fact that there is an electron withdrawing group adjacent to this carbon, which pulls the electrons, making this carbon which is adjacent to the carbonyl group acidic. And it treat with a strong base like NH2 minus, it abstract the proton. When it proton is abstracted, electron left onto the carbon and gives rise to a carbon ion generation. Similarly with esters, I can treat diethyl malonate with sodium alkoxide to give dimethyl malonate anion, and simply I can use sodium hydroxide or potassium hydroxide and treat with alkyl nitrates. Nitrate is a strong withdrawing group, making this carbon electron deficient, thus making it acidic. It's acidic enough to donate a proton. Sodium hydroxide is basic enough to accept that proton, and OH minus abstract the proton and leaves as water molecule, giving rise to a carbon ion. This is one of the methods for the preparation of carbon ions. Another method of preparation of carbon ions is by decarboxylation of sodium or potassium salts of carboxylic acids. When I heat it strongly, the O minus ions, they form the double bond. Carbon, as it has to maintain its tetravalency, these electrons are moved on to the alkyl group attached to the carboxylic acid, giving rise to a carbon ion, and it loses a carbon dioxide. Another method of production of carbon ion is adding a nucleophile to an alkene. Attack of nucleophiles to one of the carbons gives rise to carbon ion. Y minus is electron rich, and the pi electrons in the carbon carbon double bonds moves away from the carbon, creating the positive center on the carbon which is nearer to the nucleophile. This electrons rich nucleophile attacks on this electron deficient carbon, and once this nucleophile gives its electrons, the pi electrons moves onto the carbon, giving rise to a carbon ion. During the formation of organometallic compounds, we can generate carbon ion. As we know that metallic compounds are more electron rich than carbon. I take alkyl halide and treat with magnesium in the presence of dry ether under nitrogen atmosphere. I'll get corresponding alkyl magnesium halide, a Grignard's reagent. Here the magnesium in Grignard's reagent, as it is a metallic compound, It is more electron rich than carbon. It donates electrons to R, the alkyl group. Thus, the carbon in the alkyl group becomes electron rich. Hence, a carbon ion is generated. I treat alkyl halide with lithium metal. I'll get corresponding lithium methyl and lithium iodide. Lithium is more electron donating than carbon. It donates electrons and carbon becomes electron rich in presence of lithium. I take acetylene and treat with sodium and liquid ammonia. I'll get sodium salt of acetylene anion. During the formation of halides, the carbon ions are formed. I take triphenyl phosphine and treat with alkyl halide like methyl bromide. The electrons on phosphorus attacks on the positive center of the alkyl halide. As the electrons are donated to the carbon, the phosphorus gains positivity. Means it becomes electron deficient. And I take alkyl lithium and treat with this. It abstracts the proton from this methyl bromide attached with triphenyl phosphine, and it gives rise to a carbon ion and lithium bromide and alkane. In this process of formation of this halide, the carbon ion is generated. During the formation of dithiones, we can generate carbon ions. I take propane 1,3-dithiol and treat with an aldehyde. I'll get dithionate. When you treat this dithionate with butyl lithium, I'll get dithione anion. See here, 1,3-dithiol propane. If I take this as the lone pair of electrons, it attacks on the carbonyl carbon and pi electrons moves onto the oxygen. And O minus combines with HCl, H plus, and it becomes OH. Another sulfur, which has lone pair of electrons, it attacks on the carbonyl carbon and OH loses as H2O. And I get dithionate. And I treat with butyl lithium in tetrahydrofuran at minus 40 degrees centigrade. Butyl anion abstract the proton, giving rise to a carbon ion is a dithione anion. We can also generate carbon ion of weak acids. This as phenylacetylene is a weak acid, and I treat with 1 mole of tetraethyl ammonium fluoride. I'll get corresponding phenylacetylene anion salt with HF as the byproduct. These are the methods of preparation of carbon ions. Carbon ions has an unshared pair of electrons. Thus, it becomes electron rich. And it has pyramidal geometry, means it has tetrahedral structure. Means these pyramidal forms can be in these two forms. One is the one of the p or sp3 hybrid orbital is occupied by the lone pair of electrons. It gets inverted. The difference between These two, the energy difference of the two structure is 2 kilocalories when R is equal to hydrogen. If it is an electron withdrawing group like fluoride, the energy barrier is around 120 kilocalories per mole. Carbon ion is in sp3 hybrid form. And as we know that it has a tetrahedral or pyramidal shape, and one of these sp3 hybrid orbital is having lone pair of electrons. This lone pair of electrons repels the other orbital, reducing the bond angle. This bond angle lies in between 97 to 100 degrees. The inversion occurs via the transition state. In the transition state, the electrons are in the two lobes of the orbital. Hence, the methyl carbon ion is more stable than secondary primary carbon ion is more stable than secondary carbon ion is more stable than tertiary carbon ion. The excess electrons what it has, it will be stabilized when these electrons are dispersed to the other atoms. It is something like I have excess money. If I have excess money, I am unstable. I don't know how to spend it. If I spend it or if I give it to others, I become stable. Excess money is also problem. Likewise, excess electrons also destabilizes the atoms. There are various factors which stabilizes the carbon ions. One is the inductive effect, another is the conjugation effect or resonance effect, and the hybridization of the charge bearing atom and aromaticity. These are the four factors which stabilizes the carbon ion. Carbon ions are electron rich, that's why they are highly reactive and highly unstable. But when these excess electrons are shared or dispersed, then it can get comparably stabilized. As we know, inductive effect, when an electron donating group is there adjacent to this carbon ion, because of the positive inductive effect and hyperconjugative effect by the electron donating group, it increases the electron density on the carbon which is adjacent to this electron donating group. If that carbon ion is already electron rich, and because of this electron donating group, it increases the electron density of the already rich electron rich carbon ion. That's way it becomes much more rich. As it becomes much more rich, this becomes unstable. It decreases the stability. Electron withdrawing group, it takes away the electron because of negative inductive effect and hyperconjugative effect. It decreases the electron density on the carbon ion and hence it increases the stability of the carbon ion. Thus, here methyl carbon ion, it has three hydrogens which are not electron donating. Primary carbon ion has one carbon attached to it. As it is having one carbon, it is carbon is electron donating group. Methylene group is electron donating group. Hence, it becomes more unstable. Here, this carbon ion is attached to two alkyl group, two electron donating group. That's why it becomes much more unstable. In this tertiary carbon ion is attached to three carbons, it becomes much more unstable. If we look at the inductive effect, when an electron donating group is present adjacent to the carbon ion, because of the positive inductive effect and the hyperconjugative effect, it donates the electrons to the carbon ions. Carbon ions are already electron rich, and hence it becomes much more electron rich as because of the donation of electrons by the electron donating group. As becomes much more rich, it becomes much more unstable. Thus, it decreases the stability. When an electron withdrawing group is present, it takes away the electrons. Once it takes away the electrons, it becomes much more stable. Hence, methyl carbanion is more stable than primary carbanion, is more stable than secondary, is more stable than tertiary carbanions. As the tertiary carbanions has three alkyl groups, more electron donation, more unstable. Whereas methyl, no electron donating groups, that's why it is more stable. Conjugation of this anion with the adjacent atoms, it gives rise to positive resonance effect. When it is conjugated with the double bond, these electrons, excess electrons are spread over the molecule and hence it increases the stability. For example, a carbon ion is there. These electrons are moved onto the next carbon. A double bond is formed over here. Once the double bond is formed over here, this carbon has to maintain its tetravalency. That's a pi electrons moves onto the next carbon. And this carbon becomes electron rich. It is something like I have some burden I share with you. That burden. The burden is shared with you, and then again you will give back to me, and again burden is shared by me. When the excess burden is shared, both are having that burden. Hence, each will have less burden. That's why it becomes more stable. In case of benzyl carbanion, these excess electrons are shared with the phenyl group attached to the CH2 minus. Hence, it becomes more stable. Another factor which stabilizes the carbon ion is positive resonance effect. We have seen many examples over here. A carbon ion generated in a ketone in the electron withdrawing group adjacent to it. These electrons moves and pi electrons moves onto the oxygen. It becomes stable and everywhere it occurs in the similar fashion. Hybridization of the charge bearing the atom. Stability of anion depends upon the S character of carbon ion. Anion gets more stabilized when S character of the molecule increases. In case of sp hybridization, 50% is S character. In case of sp2 hybridization, 33% is S character. And in case of sp3 hybridization, 25% is S character. Remaining 75% is P character. The sp hybridized carbon, that is acetylene carbon. If it is having carbon ion, acetylene carbon ion is more stable than ethene carbon ion, is more stable than primary, that is sp3 carbon ion. Why is this so? In ethyde carbon ion, the carbon is in sp3 hybrid form. In ethynyl carbanion, the carbon is in sp2 hybrid form. In acetylene carbanion, carbon is in sp hybrid form. As the S character increases, the carbanion stability increases. Why is it so? As we know, S is the orbital which is more nearer to the nucleus. As it is more nearer to the nucleus, it feels more nuclear charge. Nucleus is electron deficient. Hence, it gets more attracted towards the nucleus, and that's why it becomes more stable. When the carbon ions forms the part of the aromatic system, it becomes stable. Cyclopentadienyl anion has 6 pi electrons. One pi electron, there are 2 pi electrons over here and 2 pi electrons over here, 4 pi electrons, and another carbon ion, cyclopentadiene anion. This act as a pi electron and it involves in the aromatic sextet formation. Hence it becomes stable. These are the four factors which stabilizes the carbon ions. In the next class, we can deal with carbon ions and its reactivity. Till then, have a nice day.